Welcome to this overview about Conflux. In this video, we'll explore what it is and how it works. Conflux is a blockchain platform that addresses some of the common challenges in blockchain technology, particularly around speed and scalability. Let me introduce the core elements. The first one is the tree graph algorithm. This reduces confirmation times and increases transactions per second, providing both speed and reliability. Next, we have the GHAST selection rule. Instead of using the traditional longest chain rule, this platform uses the GHAST rule. This allows it to prevent liveness attacks by enabling dynamic adjustment of block weights and types. Then we have the hybrid proof of work and proof of stake consensus. This is another key element that combines the security and reliability of proof of work with the efficiency of proof of stake. And finally, we have the spaces. The platform has two different spaces, core space and e-space. Core space is the original chain that provides more throughput, while e-space is designed to be fully compatible with the Ethereum virtual machine. At the heart of Conflux, there's the tree graph ledger structure. Each block not only has a single parent but also keeps a list of references to previous blocks. When transactions come into play, the platform uses the GHAST rule to choose the pivot chain. Once selected, it uses this pivot chain and the references between blocks to arrange everything in a linear sequence. This sequence determines the order of transaction execution. This is one of the biggest innovations in the network and is key to its throughput and scalability. Now, about the GHAST selection rule. This is a solution focused on preventing liveness attacks. GHAST stands for Greedy Heaviest Adaptive Subtree. Traditional blockchains like Bitcoin or Ethereum follow a rule where only the longest chain survives while others are discarded. This approach creates a conflict between scalability and security. This is where the GHAST mechanism comes in. The platform takes a different approach by replacing the longest chain rule with the GHAST rule. This makes the selection process stronger and more robust. Instead of relying solely on the number of blocks, the block type is determined based on the historical structure of the tree graph. The GHAST mechanism uses different block types and weights. There are two types, normal blocks and special blocks. When everything is running normally, all new blocks are normal. But if an attacker tries a liveness attack, all new blocks become special blocks with different weights. This increases the difficulty and prevents liveness attacks. Now, about the spaces. The platform has two independent spaces, core space and e-space. Core space is the original chain that provides more network capacity. The core space has higher throughput and supports GHAST sponsorship, but differs from Ethereum in some ways. It uses different address notation and requires specific tools like Conflux Truffle, Conflux Hardhat, and the official SDKs. This is where e-space comes in. It's fully EVM compatible, essentially a virtualized chain inside the platform. The main difference in throughput is that block time is twice that of core space, but it's still very fast. Both spaces have low gas fees. These spaces are logically independent. They have their own transactions, contracts, and addresses, but they're linked through the cross-space call internal contract, which enables communication between them. It's important to note that while these spaces are independent logically, they share the same consensus layer. The same proof of work and proof of stake mechanisms work for both. Now, about consensus mechanisms. First, there's proof of work. It's the consensus algorithm used by Bitcoin and was used by Ethereum before. Miners solve puzzles to add blocks, creating a secure and reliable network. The first miner to solve the puzzle adds the block and gets rewarded with cryptocurrency, in this case, CFX. But the platform's implementation of proof of work has some differences which we mentioned before. The tree graph algorithm and the GHAST rule. This reduces the chance of forks and ensures faster transaction confirmation compared to other proof of work networks. Apart from proof of work, there's also a proof of stake finality layer. This helps improve confirmation speed and prevent potential 51% attacks. This layer increases security by providing an independent finality decision, made randomly based on how much CFX you have staked. In POS, attackers can't execute double spending attacks just with computing power. They would need to invest enough CFX to influence POS decisions. However, if they get enough CFX, there's always a risk of manipulation. But having both consensus mechanisms lets the platform get the benefits of both while avoiding the limitations of proof of stake. This means high security, fast confirmation, and reasonable energy consumption. Conflux combines high performance, robust security, and Ethereum compatibility. These features, along with its innovative architecture and user-friendly mechanisms, make it a versatile platform for both developers and users in the blockchain space.